So I'm Jim. I do primarily work part of the RDS Postgres team. Work closely with the Aurora Postgres team. But what we're going to talk about today are just pretty general use cases of migrating from Oracle to Postgres. I've been doing Oracle to Postgres migrations most of my career. First migration I did was almost 20 years ago. Things have changed a lot. But these top 10 kind of come up all the time, right? And I've never met anybody that made all 10 mistakes, and I've never met anybody that made none of the mistakes. So just kind of from a show of hands, who has done a Oracle to Postgres migration before? Who's in the middle of doing one right now? And who's thinking of doing one? Cool, okay. So don't be ashamed, like if you've made some of these mistakes. Everybody has, right? If you were in the earlier session before when I was talking about Amazon.com migrating everything off of Oracle, Amazon.com made some of these mistakes too, right? Everybody does. But the project is to kind of learn. And why do these usually happen? One of it is because there's a looming deadline. You have an Oracle renewal coming up and your CFO says, we don't want to pay that bill, get off now. So you have a month to migrate. That's not realistic, but people try. Another one is not getting the education that you need, not learning enough about Postgres of how it works. Assuming that you know relational databases, you know Oracle, you could go ahead and just do it. You're seeing the world through an Oracle lens of Oracle does it this way, so why isn't Postgres doing it this way? That's one of the major problems as people are moving it around. It's a different engine. Right? And another one is using the migration tools and some of the shortcuts. Some of these mistakes are made by the migration tools themselves. Right? Because the migration tools are there to help you not do 100% of the work. It's there to make it do 80 or 90% of the work. So it has to make some assumptions. First one is system tuning. I've gotten this question asked a bunch of times. Is there a translation guide between the init.ora file and the PostgreSQL file? No, there's not. And don't think that there should be. Right? You could use it as general guidelines, but they're different parameters. There's a different engine. Think about it. If you were always driving a gasoline car, and then all of a sudden you got a diesel car, it would drive about the same. But the first time you went and did some maintenance and went to go refuel, you go to a different pump. And then if you had other maintenance and you wanted to tune that car, when you go with a diesel engine, you're not going to go replace the spark plugs. They don't exist. Right? So under the covers, under the hood, it's different. Even though from the surface, they might appear looking the same. So you tune things differently. Something like the SGA. Everybody says, oh, it's just like shared buffers. It's not. There's different things inside of that. For example, inside of the SGA, it contains the redo log buffer, but Postgres has a separate wall buffer. You can't tune them the same. Use them as general guidelines of where you might look at in order to tune the Postgres.conf file, but it's not the same. Tablespaces. Oracle, you need tablespaces. It's the first thing you do as an Oracle DBA, you start creating tablespaces. You use them so much that Oracle created features in order to automatically maintain those tablespaces for you. Right? And if you want to create a table, you're going to put it all in one tablespace, and indexes are going to go into a different tablespace. You don't do that in Postgres. In Postgres, every file, every table and every index is its own file. A tablespace is just simply a directory. So you get no benefits at all unless you're actually having tablespaces span multiple mount points and multiple disks. A lot of times you might be connecting to a single large storage device, and the benefits of tablespaces aren't there. There's no reason to add the extra complexity. It'll actually make things like backups for Postgres a lot more complicated if you start using tablespaces. So don't even think of using them unless you have extra disks in order to be able to do it. Case folding. So Oracle defaults all its metadata to uppercase. Postgres, it's all lowercase. So Postgres pretty closely follows the standards, the ISO ANSI standards. This is one place that it doesn't. The standard says that metadata should be all in uppercase. Postgres treats it in lowercase. So there are some migration tools that do this, and you might have a case where you're trying to make everything all uppercase so it all looks the same. You could do that by putting double quotes around everything. It becomes extremely tedious because you have to double quote everything forever. Of having like first name, middle name, last name, and users all double quoted. It just becomes error prone. Some people have a lot of application code that depends on the case of that. Make the investment early on to make that case insensitive and make that switch in the application. You will always run into bugs if you try to force the thing to be uppercase on the database. Go. So the dual table. Oracle needs the dual table. Whenever you're trying to get select sysdate from dual, in order to get that, you have a monitoring solution that's doing select one from dual that's always pinging the database. Right? It's used all over the place. Find it in the code everywhere. So what a lot of people try to do is mock up the dual table. I'll create a table called dual with one column called dummy and insert one row in there with an X. And then you could have select current date from dual. Cool. I had one customer years ago that did this, and somebody came along and did an insert into dual. Right? We didn't realize that was happening. Somebody did that, and all of a sudden everything started breaking. Somebody started doing select current date from dual, and they started getting back 2 rows instead of 1. It took us a good couple hours to figure out that that was happening. Right? Reality is, Postgres, the from clause is optional. You don't need a dual table. You could just say select current date. Use the dual table as something to search for in all your codes for some Oracle-specific code, and remove that. Right? It is one of those great keywords to find out where your code is Oracle-specific and not using just standard SQL. But if you do need to mock it for whatever reason because you have it in 1,000 places and it'd be too tedious, don't do it as a table, do it as a view. So this way you don't have that possibility of inserting a row in there. You could still, somebody could come along and change that view and make it return 2 rows or do something else to it. But if you have to, do it as a view. Synonyms. Postgres doesn't have synonyms. Heard it a bunch of times. Postgres doesn't have synonyms, so I can't migrate my application. I depend on synonyms. All my tables are in different schemas, and I don't have them fully qualified. Okay. It's cool. But it's there for a convenience. Right? So you could do select star from emp instead of select star from scott.emp. All right. But Postgres has this really cool thing called search path. Search path acts a lot like a directory path on your operating system command prompt. So if you had multiple things of java.exe or Java executables on your system, whatever shows up in the path first, that's the one that's going to run. Search path works in a similar way inside of your database across schemas. So when you have your search path, it's going to set it out of a list of schemas, and the first object that finds along that search path, it's going to return without fully qualifying it. Same way in your operating system, you don't have to put the full qualified name of java.exe, you could just say Java, and it'll just find it. Search path works the same way. So you get these 3 functions. So one of the other cool things about Postgres has multiple procedural languages, one of them being SQL. So if you have a very simple procedure or function that's really just a simple select statement, you could use it as a SQL function. And Postgres will actually treat that more like a macro. it'll do it at parse time and inject it into the overall query a lot faster than doing it at execution time and doing context switching. But here we got user1.getInt that just does a select 1, user2.getInt that does a select 2, and public.getNumber. It returns 3.14. The public schema is usually there inside of everybody's search path. If you put something there, it's going to be visible to everybody. It's like creating a public synonym. Right? But by default, if we do select getInt in order to run that function, it's not found. The default search path for Postgres is $user.public, comma public. Right? So it doesn't find it. So we could set our search path. Search path is a user settable parameter that you could set in your session. You could set it at the user level, the database level, or globally in your configuration file. That we could say user1, user2, public. So now we could do select getInt and we would return 1. Then we could just simply change our search path now to user2, user1, public. Run the same thing again and now we get 2. Just simply changing that changes which function it runs. And we could change that whenever we want, right? It's pretty straightforward. And then select getNumber, since it's in the public schema, gives us 3.14, right? So a lot of the uses for synonyms are a lot easier just using search path. You don't have to create a synonym for every one of your objects. You just set your search path based on the schemas that you care about, right? We'll take questions at the end because we have a lot of slides. Right? So nulls. Postgres and Oracle handle nulls differently. Postgres actually follows the standard, Oracle not so much. Right? But you have to account for them. This is one of those places that's more subtle, that's harder to find, that you have to do a lot of testing around in order to be able to see it. You mostly see it around string concatenation. But the crux of it is Oracle treats null as equivalent to empty string, and Postgres doesn't. So if we had our people table with first name, middle name, last name, and we wanted to concatenate that together for a full name, right? We just concatenate those strings together. In Oracle, we'll get 10 famous people going from Elvis Presley to Bill Gates to Albert Einstein. Turns everybody back. Now, we could take that exact same select statement and put it into Postgres. Now all we get is John F. Kennedy and Martin Luther King. Everybody else is null because they had no middle name. In Postgres, whenever you concatenate anything with a null, you get a null. That's where you're going to see it most often. So what you should be doing whenever you change that is you should be coalescing everything. So this way, equivalent in Postgres of NVL. Postgres does have an extension there called Aura FCE that adds a bunch of Oracle built-in functions like NVL if you wanted to stick with that. But you're much better off going using native Postgres syntax during your migrations. But even better, Postgres has some built-in functions that handle all the nulls properly that make it even easier. There's a concat with separator function that you could give it a list of things and it'll automatically do the right thing for you. You don't have to build all that up. Makes it a lot simpler as you're doing the migration. Since you have to change some code there anyway, go to some of the native Postgres syntax. This is one of the ones where you don't notice it right away. You might actually be out in production for a couple months before you bump into this one. Nulls with unique constraints. So you could create a unique index on a table with a nullable column. So we're creating it on a table called null test with column 1 and column 2, C1 and C2. And Oracle will insert in 1 and then the letter A, no problem. Then we could adjust into C1, we insert the value 1, and so C2 is null. And when we try to do that again, we get a unique constraint violation. Postgres, we create the same index, right, on C1 and C2. Same thing, we insert 1 in A, then 1 and then null, and then another 1 and another null. Postgres, null does not equal null. So it doesn't violate the unique constraints. Two nulls do not equal one another. So if you have a unique constraint on a nullable column, Postgres will accept many nulls, whereas Oracle will only accept one. So this is something that it's usually, somebody didn't think of their table design right, but it's kind of been there for years. But it's something to be able to look at as you're migrating things over to Postgres. If you need to be able to keep everything the same, you have to create special constraints on here to check for nulls. Because lo and behold, you're going to get duplicates in there when you never got them before, which is why you might not see them when you first go out to production. It might be a rare thing that might happen once a quarter or once a year, and lo and behold, you're going to get duplicates when you never got them before. Because Postgres accepts the duplicates. This is actually the standard, the way it should be done. Oracle handles it differently. So fine-tuning queries. Had an index in Oracle, and I just copied my query over. Postgres is not using that index. Right? I had a hint there. Why not? Well, part of is Postgres doesn't have hints. It just treats Oracle hints as comments. It does have hints available through an extension called PG Hint Plan, but those hints are different than Oracle hints. The operations that Postgres does under the covers, as the executor does, is different than Oracle. So your hints are going to be different. Right? The optimizer is a different optimizer than Oracle. You have some similarities. It's a cost-based optimizer, but things are still a little different. Other things is, I didn't index it on Oracle. I didn't need it on Oracle. Right? It was just fine. Why would I put an index on Postgres? Because Postgres has a lot more index types than Oracle does. You have a lot more options available to you. Instead of just a B-tree index, you have a hash index, a gin, a gist, an spgist, a brin, a bloom, a rum index, and there's many, many more that are there as extensions. There's different things that you could index on Postgres that you could never do on Oracle. So there's lots of situations where you can make Postgres perform much better than Oracle does by using some of the specialized index types. One of them, if you were in Oleg's full text search talk yesterday, we mentioned trigrams. You might be looking something up with a like query. It's always going to be slow there in Oracle because you have a wildcard before and after. Postgres, you could create an index on that. And it'll use the index with a like or an I like. It uses that gin index in order to be able to look that up, making your query a lot faster. One of the biggest things that I see as a mistake is not leveraging the native features of Postgres when you're doing the migration. People are scared, they're nervous, it's a big change. So they want it to be just like Oracle as they're getting there. I had my stored procedure written this way in Oracle. I want it written exactly the same way in Postgres. Every single time I saw somebody be that rigid that it has to be identical, the migration project fails. Leverage the power of Postgres as you're moving. There might be some places in your code, if you need to be able to run in Oracle and Postgres, that you have some if statements. If Oracle do this, if Postgres do that, that's okay. Because if you try to make Postgres act like Oracle, the project's going to fail. You're not going to get the performance that you need out of it. And it's going to be really difficult to maintain because you're not doing native things inside the database. Right? So leverage what it's there in order to be able to get the full power out of that. It has a lot of really cool features like different stored procedure languages. You don't have to do everything in PGConf. Foreign data wrappers, you could do different connections out to different database systems, or not even database systems, making REST calls. Different data types, or having the Oracle Spatial, when you go to PostGIS, Some of those things just make it so much easier if you use the specialized syntax. So we saw this in Simon's talk yesterday about the schemas, about validating JSON, validating that schema. Right? You could do it in PGCL, you could do it in C, but one of it is Postgres has a language called PLv8, which is JavaScript. JSON stands for JavaScript Object Notation. PLv8 is really good at handling JSON objects. It's really fast, so if you have some complex JSON in order to manipulate, doing it in PLv8 gives you a big performance gain. It's available to you in Postgres. Use it. Or we heard Mark mention it earlier about the specialized data types around, say, INET or CIDR. Right? Did a migration a couple years ago where a customer was collecting a lot of IP address information, and they had these Oracle packages, thousands of lines of Oracle packages, in order to convert things from Varchar 2s, because they were storing all the IP addresses as Varchar 2s, and doing arithmetic on it in order to be able to calculate whether or not things are inside of a subnet or not. Postgres has things like an INET data type that allows us to do simple things in the where clause by using specialized operators to find out, is this hosting that subnet? One line. So when we were doing that migration years ago, in order to convert those thousands of lines of package code in Oracle, I hit delete, right? Because Postgres did it all natively. But the customer was a little nervous. They're like, we spent months and months writing all this code. We need to convert it over. This made it go a lot faster. The project actually finished on time, and it performed better because it was native inside the database. Don't convert everything over to Postgres syntax. You'll never finish the project. But around specialized areas where Postgres has the unique advantage that'll save you time in the migration project, don't be afraid to use some of that specialized thing, especially around things like data types and stored procedure languages and other things like that. Leverage some of that power that's there. So exceptions. I see most people making this mistake. Oracle, just about every stored procedure has an exception handle in there. Right? And all the migration tools just migrate them over. Right? We have this function, getFirstName, right? That'll return the first name from the people table. And we have an exception in there of when no data found, return null. When all the tools convert this over to Postgres, this is what we get. So one of the reasons why so many people migrate from Oracle to Postgres, look, it's just really the header changing. Right? Postgres itself, its stored procedure language is very similar to Oracle, so things like this just work. Right? But it'll pull over everything, including the exception that's there. Right? But reality, under the covers inside of PGCL, what Postgres is doing in order to have that exception there, it uses subtransactions. Right? So not even going into that exception block, just the presence of that exception block in the stored procedure itself causes a performance hit, a measurable one. Because what that translates under the covers is this pseudocode here. It does a save point of a hidden save point. It'll run that, and then it's going to check if there's an exception. And if there's an exception, it's going to roll back that save point and then do whatever logic you have here in an exception block. Otherwise, it's going to release that save point. That gets really, really expensive to do, especially if you have a lot of stored procedure code and you have nested stored procedures. You will measure the performance hit of having these exceptions. Reality, most of the exception blocks inside of Postgres are unnecessary. You may have needed them in Oracle. Postgres behaves differently. So here we just run that without the exception block. And if we ran this for getFirstName of Gates with a capital G, we get back Bill. And Gates with a lowercase g, we get back null. There's no exception handling there. It just returned null. But the truth of it is not all the Oracle exceptions are Postgres exceptions. So if we change this a little bit, and we did add that exception block in there, we return back not found. Right? We run first name, we're still getting the null. We're not getting the not found. Because in Postgres, in order to get that Oracle-like behavior, in order to throw the exceptions with no data found or too many rows, you have to do a select into strict in order to throw those exceptions. If you don't have that keyword strict in your select into, it'll never go into that exception block. You're paying the performance overhead of having that exception block there and never using it. I see people making this one all the time. Right. Then we could finally get the not found when we have that select into strict. Everybody makes this mistake, choosing the wrong data types. So in Oracle, you have a few main data types. Your business application is you're going to have Varchar 2s, you're going to have dates, you're going to have some numbers. You might have a couple clobs and blobs, but that's about it. Oracle has some other data types, but just about every application has these. Right? That's really what you use. Postgres has 64 base data types when you just install it out of the box, and it can be extended for a lot more. When I do a tutorial about data types, it's a 3-hour-long tutorial on Postgres data types. It's not something you cover in a half hour. Right? Postgres has extensive use of data types, and it allows developers to be able to choose the right thing for their application instead of using generic data types and having to figure it out under the covers. It puts the onus on the developers. Right? And the perceived equivalent, like what we mentioned in the beginning about the configuration, the same thing applies to data types. Those perceived equivalents aren't always the same. All the migration tools, they're going to move a clob to a text field in Postgres. Right? And in Oracle, you handle a clob special. Right? So if you wanted to get the length of a clob, you have to use the DBMS packages in order to be able to get that. Postgres, a varchar and a text are the same thing. Right? They really are built upon the same thing. You could have a 1 gigabyte varchar. Right? So you don't have to move everything over to text. In fact, text is actually faster than varchars. If you want the most performance, make all your varchar 2 fields text. You probably don't want to do that because you need some length constraints on there. Varchar 100 or whatever. But it's not the same thing, that equivalent where in Oracle, a varchar 2 is different than a clob. Postgres, a varchar and a text are the same. So we could have a table that it's a varchar 4001 or a varchar 10 million and blah, right? Whatever you actually need. And we could insert into a varchar, here we're inserting the letter X 1 billion times into a varchar. And we just use the same Postgres varchar functions in order to be able to manipulate that 1 gigabyte varchar. It's just, give me the length. There's no special handling, it just kind of works. So when you're migrating things that are clobs, don't necessarily say it has to be a text field. It could be a varchar. Because varchars in Postgres are bigger than what Oracle's varchar 2s are. You might be able to just put it in a regular one and even put some constraints on there and improve your code. This is the one that gets everybody. Oracle has the number field. All your primary keys are number, right? And it goes up to number 38, which is great. You get a lot of 9s there. Everything moves that to a numeric. And you could get a numeric 38, but it could get bigger, much bigger, much, much bigger than a number 38. In fact, it could go up to 131,000 digits. You could put any Oracle number into a Postgres numeric. It is not the same data type. It's not equivalent. Putting an Oracle number into a numeric is like putting an email address into a CLOB. It is overkill for most situations. Right? It is an extremely precise data type. If you need to store things like money or financial data, that's what numeric was built for, not your primary keys, because it has that much precision and scale. Right? And you get a big performance hit for that. So because all the tools migrate everything over their primary keys, people just say, numeric, everything works great. It does. It'll take everything in. The migration tools take it in because no matter what Oracle number you have, it's going to go into numeric, and you'll never get an error. And what happens is people do that, and then they get to the end of the project, and they start performance testing, and they wonder, why is Postgres 40% slower than Oracle and using a lot more CPU? It's because all of their primary keys are set at numeric. And then when they have to go back and change that, it's an alter table, which requires rewriting the entire table. And then they have to go back and change all their Java code or Python code to handle integers instead of numerics. Right? So here's a simple test. We have two tables. T1 that has one column that's numeric, and T2 that has two columns that are numeric. And we just generated a bunch of code, 1 million rows in the other one and 10 million rows in the other one. So it's so we could do a join between the two. For every row in T1, we get 10 rows in T2. Right? So we just do a simple select count star of joining those two together. Right? Ran on my laptop over here in 2.7 seconds. Do the same thing as big ints, just as integers. Could have even done it as integers instead of big ints. Generate the same thing. Now runs in 1.9 seconds. A 40% performance difference by having your keys all as integers instead of numerics. You're getting that 40% performance hit on every single primary key lookup if you have them as numerics. Right? Even some of the like tools and everything might create a number field that does an alias over numerics. You're still paying that performance hit. Right? It's like this is the biggest source of performance hits as you're migrating over to Postgres. It's not that Postgres can't perform. It's that the migration was done wrong with the wrong data types. When you're doing your migration from Oracle to Postgres, spend all your time on the data model up front. It will save you days, weeks, months of time at the end. If you spend that extra couple days getting all the data types right in the beginning, laying the foundation of the house down so this way everything else is built strong on top of it, you'll get an application that'll perform just as well as Oracle, if not better, if you make the right choices, because Postgres is different and it gives the power to the developers, and you have to make the right choices. You know what your data is. So make the right choices of the data type. Choosing between an integer, a big int, small int, choosing the right timestamp fields and date fields, choosing inet, CIDR, Varchar, those things, using a Boolean field instead of a Varchar 1 makes a big difference, and it all adds up. If you make those right choices of those data types, day one of your migration, you'll have one that's going to be able to perform as well as Oracle. So in summary, top 10. Again, I've always found nobody's ever made all 10 of the mistakes, and nobody's made none of the mistakes. Right? Tuning the system. Right? You have to learn Postgres in order to be able to tune it properly. Right? Don't fall down into the traps of thinking that everything has to be like Oracle. Right, of using all the table spaces and using all the features the same way. Right? Don't get trapped by mocking up Oracle like the dual table and creating all these things in order to be able to make it a little bit easier. It's going to lead to bugs down the road. And when you're thinking about performance, spend the time early on those data types and do the design stuff early on. It makes a huge difference. Thank you.
Jim, I have a query. So, great talk. We have done this thing for some of our work. One specific query, if I attempt a migration with Oracle, either using the OCI APIs or using tools like Ora2 PG, I have to also specify that the fact that there is an MBCS4 encoding for the Oracle database by default, especially in the 11x series.
Yep.
So now when I attempt to migrate, one of the issues I face is that the row goes beyond 65535 the moment I do a mapping into PostgreSQL.
Okay.
So do you have any thoughts about workaround for that? Because then I'm just doubling up. So if I have 100 terabyte to play with, I'm now looking at 400 plus terabyte of data. So.
No, because I didn't hear everything you said, but we could talk offline.
Okay, sure.
Hello. Regarding that search path, if the function is in different places, how it will recognize which one it will execute?
If it's in a different
The same
place,
function is in different
it's whatever's first in the search path. So you could have that same function that we had, getInt, right? Whatever your search path is, if your search path is user1, user2, it's going to run the user1 version. If it's user2, user1, it'll run the user2 version of it, right? So you could have duplicates there. Same like with Oracle, you create multiple multiple things that are there. It's just a precedence of the search path of the. Yeah.
One more question: when to use text?
As much as you can. When to use text, as much as you can. If you have string data that doesn't have a limit on there, so if you don't have to do like a Varchar 100 or a Varchar 1000, it's just a Varchar. Use text. It's actually faster.
Any more questions? Okay, thank you. Thank you,
Cool.
Jim.
Thank you.